Chemical elements. This is June of 2025 and in today's video we will discuss the chemical elements. Credit goes to ChatGPT and Google AI because most of the information in this video is drawn from a couple of AIs. Content of today's video include chemical elements, periodic table, elements of life. Chemical elements are the fundamental building blocks of matter. They are pure substances that cannot be broken down into simpler substances by ordinary chemical processes. Think of them as the basic ingredients from which everything around us is made. Chemical elements share a key characteristics, and they are composed of one type of atom, cannot be broken down by chemical means, elements are organized in periodic table, and they exist in various forms. Let's look at them one by one. Composed of one type of atom, meaning each chemical element is defined by the number of protons in the nucleus of its atom. This number is called the atomic number and is unique to each element. Example is oxygen. It has 8 protons and neutrons in its nucleus orbited by the 8 electrons. They cannot be broken down by chemical means, meaning chemical reactions can rearrange atoms to form new compounds, but they cannot change the identity of an element. Elements are organized in a periodic table. The periodic table organizes the elements based on their atomic number and similar properties. We will discuss this further in detail in a moment. They exist in various forms. Elements can exist as individual atoms, as molecules made up of 2 or more atoms of the same element such as oxygen gas, O2, or as part of complex compound like water, H2O. Let's have a look at the example of element. In this case, it is lithium. Lithium has 3 protons, 3 neutrons in its nucleus, and 3 electrons orbiting around the nucleus of an atom. Another example is water molecule, H2O, meaning it has 2 hydrogen and 1 oxygen bonded by the electrons. Periodic table. The periodic table of elements is a tabular arrangement of chemical elements, ordered based on their atomic number, electron configuration, and recurring chemical properties. Between the 1700s and 1800s, scientists began discovering individual elements such as hydrogen, oxygen, and nitrogen. By the early 1800s, around 30 elements were known. Johann Debruyner, excuse me if I'm not pronouncing that correctly, grouped elements in 3 based on similar properties. Example, lithium, sodium, and potassium. Middle element properties were roughly the average of the other 2. John Newlands arranged elements in order of increasing atomic mass. Every 8 element had similar properties, like musical octaves. Dmitry Mendeleev arranged elements by increasing atomic mass, but also grouped them in similar properties. Crucially, he left gaps for undiscovered elements, for example being gallium and scandium, and predicted their properties accurately. Henry Moseley discovered the atomic number of protons was a better organizing principle than atomic mass. That solved inconsistencies in Mendeleev's table. Currently, the periodic table is arranged in rows, columns, and blocks. Rows, also called periods. Horizontal rows, 1 to 7, represent increasing energy levels of electrons. Columns, also called groups, are vertical columns from 1 to 18 containing elements with similar valence electron configurations and chemical properties. Blocks. S block is in red. Groups 1 to 2 are alkaline earth metals. P block is highlighted in orange. Groups 13 to 18 include nonmetals, halogens, and noble gases. D block, in blue, transition metal groups 3 to 12. F block is highlighted in green, lanthanides and actinides. They attach at the bottom. Building blocks of life. All organisms are built from the same six essential ingredients: hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. Let's talk about them in detail. First, hydrogen. Hydrogen is the most abundant chemical element in the universe, constituting about 75% of normal matter. It is colorless, odorless, non-toxic, and highly combustible. Hydrogen can be found in water, hydrocarbons. Hydrogen plus carbon are fossil fuels, petroleum, natural gas, and coal, and organic compounds. Microbial metabolism or naturally occurring rock-water interaction, hydrogen gas can be created. Bacteria consuming free H2 may be oxidized photochemically in the atmosphere or lost in space. Hydrogen is produced by hydrogenases and nitrogenases enzyme in many microorganisms. Hydrogenases is the enzyme that catalyzes reversible oxidation of molecular hydrogen H2. Nitrogenases are the enzymes that are produced by certain bacteria, such as cyanobacteria and rhizobacteria. These enzymes are responsible for reduction of nitrogen into to ammonia (NH3). Nitrogen fixation is required for all life forms, with nitrogen being essential for the biosynthesis of molecules, nucleotides, and amino acids that create plant, animals, and other living organisms. Next on the list of elements is carbon. Carbon, from Latin col, is a chemical element with the symbol C and atomic number 6. It is nonmetal and tetravalent. Carbon makes up about 0.025% of Earth's crust. Three isotopes are naturally occurring, from 12C to 14C, is radionuclide, decaying with a half-life of 5,700 years. When combined with oxygen and hydrogen, carbon forms many groups of important biological compounds, including sugars, lignins, chitins, alcohol, fats, aromatic esters, and terpeners. With nitrogen, it forms alkaloids. With addition of sulfur, it also forms antibiotics, amino acids, and rubber products. With addition of phosphorus to these other elements, it forms DNA and RNA, the chemical code carriers of life, and adenosine triphosphate, ATP, the most important energy transfer molecule in all living cells. Adenosine triphosphate is a nucleoside triphosphate that provides energy to drive and support many processes in living cells, such as muscle contraction, nerve impulse propagation, and chemical synthesis, found in all life forms. It is often referred to as the molecular unit of currency for intercellular energy transfer. Next on the list of chemicals is nitrogen. Nitrogen is a chemical element with the symbol N and atomic number 7. It is nonmetal. two atoms of element bond to form in two, forms about 78% of Earth's atmosphere. Nitrogen compounds constantly interchange between the atmosphere and living organisms. Nitrogen first must be processed, or fixed, into usable form, usually ammonia. Same nitrogen fixation is done by lightning strike, producing the nitrogen oxide, but most is done by the diazotrophic bacteria through enzyme known as nitrogenases. Ammonia is taken by plants, used to synthesize protein. Plants are digested by animals to synthesize their protein and excrete nitrogen-bearing waste. When organisms die and decompose, undergoing bacterial and environmental oxidation and denitrification, returning free nitrogen to the atmosphere. Next on the list is oxygen. Oxygen is a chemical element with the symbol O and element number 8, reactive nonmetal and oxidizing agent. Oxidizing agent is a substance in a redox chemical reaction that gains or accepts receives an electron from reducing agent. All eukaryotic organisms, plants, animals, fungi, algae, and most protists need oxygen from cellular respiration, with, which extracts chemical energy by reaction of oxygen with organic molecules derived from food and released carbon dioxide as a waste product. Commonly, industrial uses of oxygen include production of steel, plastic, textiles, brazing, welding, cutting of steels, rocket propellant, oxygen therapy, life support systems in aircraft, submarines, spaceflight, and diving. Next is phosphorus. Phosphorus has a symbol P and atomic number 15. There are two forms of it, red and white phosphorus. Because it is highly reactive, it is never found as free element on Earth. Phosphorus is used as flame retardant, food additive E338, used to acidify food and beverages such as cola, jams, providing tangy sour taste. It is also used as preservatives, baking powder, detergent, and fertilizers. Last but not least is sulfur. Sulfur is a chemical element with atomic number 16 and symbol S. It is abundant, multivalent, and nonmetal. Under normal conditions, sulfur atoms form cyclic octatomic molecules with the chemical formula S8. Sulfur at room temperature. Uses include natural gas, petroleum, fertilizers, sulfur acid, matches, fungicide, skunk scent, believe it or not, grapefruit, garlic, and organosulfur. It is present in amino acids, as well as vitamins, such as biotin, otherwise B7, and thiamine, B1.